Hi and welcome to Jawad's Academy. Today's lesson is about evaluating the limit of any relation. So I'm going to show you three different approaches in order to evaluate the limits of any relation. The first one would be direct substitution, then the second would be simplifying or rationalizing, then substitute, and the last one would be change of variables. So an example would be, the first example we're going to use as limit of x approaches 1 of a rational function would be x squared minus 5x plus 2 over 2x cubed plus 3x plus 1. So we approach direct substitution, meaning that substituting for x on top and bottom positive 1, since as limit of x approaches positive 1. So once we substitute, we don't need to write as limit of x approaches 1 anymore. We're just going to substitute for x positive 1 here. Squared minus 5 times 1 plus 2. And we have 2 times 1 to the power of 3 plus 3 times 1 plus 1. And this would equal to, so we have 1 minus 5 plus 2, and in the denominator we have 2 plus 3 plus 1, and this would equal to, would be negative 2 over, we have 6, and this would equal to, simplify in order to reduce, would be negative 1 over 3. So we got an exact value as a limit of x approaches 1. And if we were to get 0 in the denominator of this rational function, then we have to use different approach where we have to simplify, then substitute in order to find an exact value. So here's another example where we need to simplify before substitute. Question number 2, example number 2 would be as limit of x approaches 1, x squared minus 1 over x minus 1. If I were to substitute for x1, I know we're going to get a 0 in the denominator of this rational function. So let's simplify. What I mean by simplify, so we're going to use all those basic skills that we learned in order to simplify this rational function. So I can see now I can factor the numerator. It's difference of square factoring. So I'm going to write again as limit of x approaches 1, and I would factor this relation x minus 1 and x plus 1, and denominator stays the same. And also my restriction is x cannot be 1 before we simplify. So this cancels this. Now what I have is as limit of x approaches 1, x plus 1. Now I can directly substitute for x right here as positive 1, and the answer would be 2. So this is how we take the second approach in terms of simplifying. And let me give you another example of in order to simplify before we substitute. So we're going to do a radical question in terms of rational relation. So we have as limit of x approaches 0, and we have square root of x plus 1 minus 1 outside over x. In this case, if I substitute for x 0, I will end up having 0 in the denominator. It doesn't matter if you have a 0 on top, but it does matter if you have a 0 in the bottom of this rational function. So what we do, we simplify. What kind of approach we're going to take for this question in order to simplify? We do rationalization. So when we're dealing with radicals and square root and rational functions, so we gotta think of rationalization. In this case, we're going to rationalize the numerator because we have square root on top of this rational function. So we're going to multiply top and bottom by the conjugate of the numerator. Conjugate means the sign, the middle sign of this two term, in between these two terms, changes to positive. So we write as square root of x plus 1 over square root of x plus 1 plus 1. So we rationalize the numerator, meaning that we multiply top and bottom by the conjugate of this. So everything else stays the same except the sign switches from negative to positive. If it was positive, it will go both top and bottom negative. Now we want to expand. So we're going to expand the numerator and we leave the bottom in multiplication form, but we don't need to expand in order to simplify and evaluate this limit of x approaches 0. So to expand, I'm going to show you this times this, it would be just x plus 1, which because square root cancels out. And this one, square root radical of x plus 1 times positive 1 would be just positive square root of x plus 1. And then this times this would be negative 1 times square root of x plus 1. And negative 1 times positive 1 would be negative 1 over x bracket open. As we say, we're not going to expand. We're just going to leave it in multiplication form. And now we're going to simplify. So we know that this and this cancels out. And then we have x plus 1, subtract 1, and negative 1 and positive 1 cancels out. So what we have here, as limit of x approaches 0, on top we only left with just x right there. And in the bottom we have x, bracket open, square root of x plus 1, plus 1. Now we simplify further. We can see x and x cancels out, and we're going to state our restriction that x cannot, of course, equal to 0 since we're simplifying. So what we have now, as limit of x approaches 0, we have 1 on top, since x and x cancels each other at once. And in the bottom we have square root of x plus 1 plus 1. Now we can directly substitute after we simplified for x 0. Since we're going to substitute for x 0, we no need to write as limit of x approaches 0 anymore. So we have 1 over 0 plus 1 would be just radical square root of 1 plus 1. And we have 1 over square root of 1 is 1 plus 1. And this would give us half. So this is another way of simplifying a rational function in order to evaluate as limit of x approaches any given value. Let's do the third approach. We said change of variables. And we're going to approach this method now, change of variables. So here's an example of change of variables. So let me grab another clean sheet of paper right here. And our fourth example would be change of variables. As limit of x approaches 8, and we have cube root of x minus 2 over x minus 8. So you can see that we have a cube root, higher roots than just a square root. If it was a square root, if it was a radical, we would use rationalization. But in this case, we do change a variable in order to simplify. Because if we were to directly substitute for x8, we will have 0 in the denominator. So we do our best to simplify before we substitute using change of variable method. So what do I mean by change of variable? We always let the higher roots, let's say let y be cube root of x. And then we need to also isolate for x. So we got to solve for x here. So the opposite of the reverse of cube root would be cubed. So y cubed equals x. Now we're going to substitute for x, y to the power of 3. And for cube root of x, y. So we're changing the variable from x to y. That's what change of variable means. So here we have as limit of x, instead of x, we substitute y cubed. So as limit of y cubed approaches 8, would go to cube root of x, we said let it be y minus 2. And we said again, substitute for x, y to the power of 3. In order to change the whole variables. And there you go. So we changed the variable. As we said in the beginning, let y represents the cube root of x, and then we have to isolate for x using this equation. So x would equal to y to the power of 3, the opposite of cube root, and then we reverse the variables, switch the variables from x to y. And here we have now, we're going to simplify this. We should be able to simplify this. Here we couldn't do rationalization because it wasn't radical. It's a higher root, roots than square roots. So here we're going to simplify before we substitute for as limit of y. Now in order to get y by itself, so we know that y cubed is approaches 8, then y would equal to cube root of 8 is 2. So y approaches 2. We have y minus 2, y cubed minus 8. If I were to substitute just for now, for y2, I would get 0 in the bottom still. But we can simplify this relation using the difference of cube factoring in the bottom. Hoping that you do remember difference of cube factoring. If not, you can go back to those other lessons of video clips that show factoring, all types of factoring using syntactic division and higher than quadratic relations, cubic and quartic and degree 5 factoring. So let's get back to this question. So we said this is a difference of cube factoring. So we have y minus 2 and y squared plus 2y plus 4, and that's the factor of the bottom. And y minus 2 we left with as the numerator. So before we simplify, we state our restrictions. Y cannot be 2 because we are simplifying top to bottom and they each goes once. So what we have now is still we're going to write as limit of y approaches 2 because we haven't substituted yet. We're just simplifying here this rational function. So we left with 1 over y squared plus 2y plus 4. Now we go ahead and substitute for y2, and I'm sure we're not going to get 0 in the bottom anymore because we simplified this rational function. So we have 1 over 2 to the power of 2 is 4, 2 times 2 is 4, plus 4 we have 1 over 12. So that's how we use change of variable in order to evaluate a limit of any given higher radicals, higher roots. But in case if you did your best to simplify and then you substitute and still you got 0 as the denominator of given rational function, then at the end you can conclude that as limit of x approaches that value does not exist. But so far we did our best to simplify and then we got a value for these limits. So I'm hoping that this lesson was useful and productive, but please go back and practice the same questions, very similar questions that I have done from your textbook, and I'm sure you're gonna do well. And remember that not just writing what you see from the board and from the notes, always write what you hear in order to make your notes valuable for yourself. Don't forget that. So I'm going to end my session for evaluating limits right now. Please don't forget to subscribe. If you have any question or comments below in the comment box, leave your question and hopefully I can get back to your questions. So till then, take care and wish you all the very best.